Welcome to today's video. Today we'll be talking about finding angles and sides using sine of both right triangles and non-right triangles. So for an example, we'll say that they give you a right triangle. They give you the angle. They give you a base, and you have to find the hypotenuse. So, as you remember from the acronym SO, CA, TOA, is a good way to remember what sides of the triangle you're dealing with when you're using either sine, cosine, or tangent. In this case, we'll be using sine, so it's opposite, which in this case would be this one, opposite, over hypotenuse, which the hypotenuse is always across from the right angle, is always the longest side of the triangle. So this is our hypotenuse. So actually this is about example because we're only given an adjacent side. So we'll say this one is actually 5 now. So now we have an opposite and the hypotenuse side. So now that you have this set up, you can set up sine of your angle, which is 25 degrees, over 1, because we're setting a proportional relationship to the what it equals to. So one side length's here, one side length's here. So you compute this out and you get 5 equals x times sine of 25. To solve for x, you divide by sine of 25 on both sides. Compute that out on your calculator. Make sure your calculator is in degrees for whatever reason if it's not. So you do 5 divided by sine of 25 and you get x equals 11.83. We'll go to the round to the nearest hundredth place. So if you want to, you're more than welcome to check it. Just plug in 5 over 11.83 equals sine of 25. So 5 divided by 11.83 gets you 0.42, and so does sine of 25. So you know that's correct. Then we'll do the exact same thing to a similar way. We have your right triangle. We'll say this is now 45 degrees. And we're given that this is, we'll say, 20. And we're trying to find this. So, once again, you'll set up your proportional relationship. You do sine of the given angle over 1 equals your opposite, which is x, over 20. And you cross multiply. Then you get boom, boom. This goes here, that goes there. Then you get 20 sine of 45 equals x. Wow, that makes it really easy. Plug it into your calculator. 20 sine of 45 degrees. And you get x equals 14.14. If you really want to make sure you're correct and double check your work to see sine of 45 should equal 14.14 over 20. So 14.14 divided by 20 is 0.707, and sine of 45 should be 0.707, which it is. So good job, we found it. Finally, the ACT may put on, given that you know that this side length is 5, this side length is 8. You don't know your hypotenuse, and you have to find theta, or your angle, which is in theta. So this is your final answer that you're looking for. So, you know that, looking back up here, that sine is opposite over hypotenuse. Here's your opposite side, here's your hypotenuse. There's one problem. We don't know the hypotenuse, so how do we do this? If you remember Pythagorean theorem, which I'll abbreviate and put Pythag theorem, is a squared plus b squared equals c squared. A being one of the sides, b being one of the sides, and c being your hypotenuse. You can interchange a and b. Usually I like to do a being the smallest, then go up to b being the middle one. So we'll say that 5 squared plus 8 squared equals c squared. Compute that out, that is 25 plus 64 equals c squared. 25 plus 64 is, come over here, 89 equals c squared. So c squared is square root of 89. And if you want to get into decimal format, you could say c is 9.43. So, now since we know our hypotenuse is now 9.3, we can now find for theta. Once we know our sides, we can do the inverse of sine, is how we find the degrees if you know two side lengths. So you basically would plug in your calculator inverse sine of your opposite over hypotenuse. It gives you your theta in degrees. So in this case, sine of -1 of 8 over 9.43 inverse sine 8 divided by 9.43, we should get 53.03 degrees. And that would be your degree measure, be 58.03 degrees. So, to sum this up, you can find, knowing if given one of the sides, you can find out the other side by setting up proportionally of sine equals opposite over hypotenuse. And if you know your sides but don't know your degrees, you can take the inverse sine to do the reverse of it. Plug in your opposite over hypotenuse, will give you your degree, which gave us our degree. The ACT will also include non-right triangles. So you may be asking, why would they include non-right triangles? Because some of you may remember this law of sine, which says the sine of A equals A sine of B over B equals sine of C over C. Relating that to a non-right triangle, go like that. This is a non-right triangle. It's an acute angle. We'll just say that's not a very good triangle, but this being little a, I guess I should reverse that. This is little a, this is big A. Big A, little a corresponds to this side, B corresponds to that side, C corresponds to that side. Usually C is your bigger one. So, for example, they'll give you a triangle. They'll put something, degree measure on it, and say this is, we'll say this is 110 degrees. And they'll give you, and say this is we'll say this is 30 degrees. You don't know this angle. You know this side is that doesn't work out actually. Hold on. Gotta draw a better triangle. There we go. That's a semi-decent triangle. Just think this is a straight line. There we go. Okay, there's a straight line. They'll give you, say this is, let's say 40 degrees, and this is 10, and we'll say this is 3. And they want you to know what this side length is. So you may be asking, that's just a lot of stuff. So we'll take it one step at a time. First, we got to figure out this degree measure. So you know that supplementary angles equal 180 degrees. So we know 40, and this whole line's 180. So 180 minus 40 gives us 150. So there's our angle there. Now knowing that, we can use the equation from above and say that the sine of 150, plug in x for that, equals sine of 10 over 3. You cross multiply like you would with the other problems. You get 3 sine of 150 equals sine 10 times x, or you can do x of 10. You get x by itself, you divide both sides by sine of 10 equals x. You can plug this full thing into your calculator. 3 sine of 150 divided by sine of 10, and you get x equals 8.63. Or if you want to round up, it'd be 6/4. So if you want to make sure that's correct, you can plug it back into the equation. 150 over 8.64 equals sine of 10 over 3. You do sine of 150 divided by 8.64. You get 0.5. Sine of 10 over 3. You get 0.05. So they're both equal to each other, saying that this is 8.64. They can also ask you, based off of that, they can go the other way around and ask you a given the triangle and given the length, and say this is 75, and so this being, we'll say 18, this being 7, what's this angle? So you may once again be asking, boy, that's a lot of lots of stuff going on there. So like the original problem, supplementary angle, so 180 minus 75 equals, I believe it's 105. So we know this is 105. Using our equation from before, saying sine of A over A, sine of B over B, sine of C over C, yada yada yada. Basically saying degree over the side length exactly across from it, degree equals the degree over the side length across of it. So we'll say that sine of x over 7 equals sine of 105 over 18. You cross multiply, you get 7 sine of 105 equals 18 sine of x. You solve for x. Well, first you divide it by 18 to get sine of x by itself. If you want to, you can just commute it out and just keep it in your calculator. Over 18, you get 0.37. Rounded would be 0.38 equals sine of x. How do you get x out of sine? You take the inverse of it. So it'd be sine of the inverse of your answer. You plug that into your calculator, you get x equals inverse sine equals 22.06, somewhere around there, plus or minus a few. If you get relatively close, you're good. Degrees. So, because of that, now this is 22.06 degrees. Then, like we did before, you can check it. Basically, I know that's correct. So, to wrap things up, basically, on the ACT, they'll go over a little bit of this stuff. You won't have, I don't believe you have to know how to do this per se, but you do know how to set it up. So if they do say, hey, what's this? You can say, oh, this is this over this, or yada yada yada. So, hope this video was helpful to you. If you'd like to comment down below any additional videos that you'd like me to go over any topics concerning the ACT math section or any math class, either be like algebra, geometry, trigonometry, pre-calculus, calculus, that stuff. Comment down below what concept you want to go over, and I'll get that out to you. And I'll see you next time.